Hello and welcome to another tutorial. We're going to continue our discussion on access modifiers for member variables or fields and member functions or methods. And we saw that in Java you have to explicitly declare an access modifier for every field and every method, even constructors and even the class. The difference was that the class can only be public or package level access, which means either you type public or you type anything. Unless the class is part of the scope of another class, then you can also use, for example, private. But in general, if your class declaration is directly inside the source file, then you cannot use anything but public or basic. You can only write public or write nothing. Then it becomes package level access. Now, I wanted to mention that we said that Eclipse has this nice feature outline. As you can see, a package level access is triangle, a blue triangle. A public is green, a circle green. A protected is diamond yellow, and a private is a square red, right? Not only the shape of the symbols are different, the colors are different, and we said that Eclipse differentiates between method and fields with a white dot inside the circles, right? So methods, the symbols are full and usually larger. Fields, the symbols are smaller and they have a white dot in them. So not only it's color coded, it's also shape coded, and it gives you lots and lots of information, right? So it's a very nice feature to have. So let's put this back public, and we said that making a class public is if another class or another type in another package wants to access the fields of an instance of this type, which is in a separate package. First, it has to be able to access the type itself. That's this whole business of declaring a public here means, right? We say that other types in other packages now allowed to have access to this type, which means they're allowed in the scope of that other classes that are in other packages, they're allowed to create instances of this type, right? So that's the whole business of restricting the access to the type itself. But then if a class in other package can access this type, the question is, and if it creates an instance of this type, the question is which part of the state of this type it can directly access. And we saw that public, protected, private, and no access modifier, which means package level access. Our first example was we create this access modifiers class, right? This in a package called classes, and then we have in another package called OOP, we have this access modifier demo, right? And we said that in the main method, we can create a local variable, right, of the type access modifiers. And because this type is public, this class, in the scope of this class, which is in another package, this class has access to this type. So it can create basically an instance or an object of this type. Note that not only the type has to be public, but the constructor has to be public, because this class, because we're creating an instance of these access modifiers inside this demo class. So we should be able not only to access the type, but access the constructor. And we said that if there is no explicit declaration of the constructor, the compiler provides a public no-arg constructor. And we can see that by looking at the bytecode. So if I go to navigate and look at the access modifiers class bytecode, if I put this side by side, and as you can see, there is a constructor. So the constructor, the name of the constructor is like a special method. The name is exactly the name of your type or class. And you see the compiler puts a public in front of it, and then it doesn't take any parameters. And the constructor is a special method in the sense that it doesn't specify any return type, because you cannot use the constructor method by itself. You have to use the new operator, right? And then new tells the JVM special instructions that what happens when you call this kind of a special method, which means create a type and return the object itself, return a reference to the object, right? That's the difference between this constructor, which are special methods, and calling the regular methods, right? Regular methods have to have a return type. JVM needs to know that. Constructors, special methods, you have to use them with the new operator. And then in conjunction with the new operator, JVM knows that instead of looking for the return type of this method, which is a constructor, it has to return a reference or a pointer to that object, right? And you see this class access modifiers didn't have an explicit constructor, but we do have a constructor in the bytecode. And the constructor is very simple. It just loads this And then remember, we said that in the object-oriented paradigm, whenever you create an instance of a class, you have to first initialize the superclass. That's why it has a special a keyword called invoke a special, which means invoke a method which is a special. And we said that constructor is basically a special method. So it's basically calling the Java lang object, the constructor that doesn't take any parameter from Java lang. And that means that every class that you don't explicitly mention that it extends something, it automatically extends the object class, right, from Java lang object. So when there is a constructor for the default constructor for this class, it has to first call the constructor of the superclass. So it says this, and then invoke a special, this again, iconst1, and then it loads one. So basically what happens, you see these fields are initialized. So what it does, in the constructor, it actually initializes the fields. And the reason is that these are not a static method. So therefore, as you can see, these fields get initialized in the default constructor that the class puts, right, that the compiler puts. Iconst1, iconst2, iconst3, and iconst4, right? So 1 is assigned to x1, and then basically 2 is assigned to x2, 3 is assigned to x3, 4 is assigned to 4, and then we return. Now note that what happens if I explicitly type the constructor access modifiers, right? I provide a no-r constructor, but I don't assign values to basically fields, right? x1, x2. So let's see what happens in the constructor. So as you can see, what happens here is that even if I don't do anything, let's say I type something, hello. If I save, Eclipse compiles. Note that what happens, Eclipse first calls the superclass constructor. So there is an explicit line like this, super brackets, right? And this is explicit, we're not typing it, we can type it. Remember, we said that super points to, it's a keyword reserved to point to the superclass. In this case, it's the object, right? Java lang object. And then what happens here is that, but because we're not using the dot operator on the super, we're using round bracket, it means point to the superclass constructor. And compiler knows that when you don't put any arguments in this round brackets, it means point to the constructor of the superclass that doesn't take any parameters. Obviously, if the superclass doesn't have a constructor with this signature, is going to complain, right? But then object class from Java lang object has a constructor that doesn't take any parameters, so this compiles. If you don't write it, the compiler will put this as the first line, right? The first line of code for the constructor of a class has to be initializing the superclass, which means calling the constructor superclass, the superclass constructor. And then note that where this line happens in the bytecode is invoke virtual here. So basically from loading this string literal, and then or basically from here, getting the static field out from system, loading the string literal, and then calling the print line method, right? So all this line is all this line for initializing this method is automatically put in the constructor code by the compiler, so you don't need to worry about that. When you write this like this initializing the fields of a class, non-static fields, by using the assignment operator, this is a syntactic sugar. What happens in reality is that the compiler actually rewrites this like this. Compiler creates something called instance initializer, and this is a topic that we will look at in the future lectures. It's called instance initializer. And what happens basically, instance initializer means this kind of initialization is basically is nothing but a syntactic sugar. So this kind of initialization, using assignment operator, saying that this field equals this value, it's a syntactic sugar for an instance initializer. An instance initializer is just a block of code, but it doesn't belong to any method, and it's not declaring any method. It's just an empty block of code, right, that directly inside the scope of your class. this is called instance initializer. So what the compiler does this. Basically, compiler, I'm going to add a _1 to this naming to differentiate them from. So compiler does this: x1, x2, x3, x4, right? x2, x3, x4. And then when the JVM loads this class into memory, the definition, it actually initializes these values to the default, which is 0, right? But then in the instance initializer, compiler writes this code. 1, x2 underscore 1 is 2, x3 underscore 1 is 3, and x4 underscore 1 is 4, right? So compiler decomposes your declaration and immediate initialization into two parts. One is declaring the fields, because when the class is loaded into memory, JVM needs to know the properties of this class, which means the fields. So there are 4 fields I've typed in, they're all public, the name is this, right? 4 fields. And then this is part of the initializing the instance. Whenever somebody creates an instance of this class, these fields have to have these default values 1, 2, 3, 4, 4, right? So, and then what happens in the actual constructor, when somebody creates an instance, the compiler puts a call, or basically compiler copies the code in all of the instance initializers. So that's actually what happens. So the compiler, if you add some instance initializer blocks to your class, and you can have multiple of them, right? Sysout, for example, instance initializer. So I have 2 instance initializers here, and I'm going to remove this line, right? So my basically constructor is empty, but what happens in reality is that the compiler copies these codes, whatever. So compiler at the first line of the constructor, the compiler adds a call to the constructor of a superclass, and then the compiler copies all the codes inside all the instance initializer of your class after the first line, which is a call to the superclass. So if I basically create an instance of this, let me hide this. So as soon as I create an instance of this type, right, the constructor is called, and then it's going to print those that line, this line inside in this instance initializer, because all these lines of code have been copied in the bytecode. They've been copied into the constructor code. So if I run this, you see instance initializer, right? So all these lines copied, and this line was copied right after the call to the superclass in the constructor, and it happens for all the constructors, right? So your class might have 5 or 10 constructors, and the compiler automatically copies all this code in this. So this kind of assignment, x1 equals 1, x2 equals 2, this is a syntactic sugar for separating the declaration of the fields and initializing it. And note that declaration happens basically is important when JVM loads the class file into memory. Then JVM understands the structure your class, and then instance initialization happens when somebody creates an actual object of this class, of this type, right? And then these fields get initialized. So as long as nobody creates an object, these fields have actually the default values, which for int is 0, right? So I just want you to understand the difference here. So I'm going to remove all these, and then go back here. Let's run the constructor. Obviously nothing happens. Now we saw that if we have public, protected, private, and package level fields, right? And the type is public, so every class in other packages can access this type. And not only that, the constructor was also public, which means everybody can create. So if I set the constructor to private, now I get a compilation error, because although the type is public, then nobody can create an object of this type because the constructor is private. So the access, so there is a difference between the type being public and somebody being able to create an instance of that type, even though they can access it. Now you might ask, what's the purpose of making a type public but having a private constructor so nobody can can create an instance. So the purpose of that is something like you can, because sometimes you just need to have access to the type. For example, it could be the return type of a method. So I can say public static and this type do something. It doesn't take any parameters and does so. Obviously in order to or maybe let's say void, and somebody passes a parameter of this type x, right? Now this code is perfectly valid and it compiles, even though this class cannot create an instance of this type. It still needs to be able to access the type, because every parameter of a method has to have a type, and if another class is not allowed to access the type, then it cannot use that type as a parameter inside one of its method. All right, so I want you to understand that. If we set the, let's say we get an int and then we say that the return type of this method is of this type. Now this method has to somehow construct an object of this type, and the only way is to call the constructor. So, and because this class doesn't have access to the constructor, it cannot create an object of this type. So this doesn't work, because even though we have access to the type, we cannot create an instance and return it, right? Whenever your method says we're returning at some type, it means you have to have an instance of that type, right? If it's a class type, object type, you have to create an object and return it. But for the method signature, that's totally valid, right? And again, then because we are accessing this type in this method, we only have direct access to the public, right? The public state of, let's call it obj, for example. Basically obj.x1. So if I use the dot operator, we only have access to x1 and y. Remember, we added the y somewhere down here. Yes, this one was public. So I'm going to remove this and go back here, and if I use the dot operator here, as you can see, we have two methods, a lot of public methods from the object class. You can actually configure Eclipse to not show these methods, right? Because most likely we don't really care that much about these wait, notify. So I will show you in the future lectures how to configure Eclipse to not show these methods from the object class, right? So x1, this is a public field, it's a green circle, and then add and then do nothing. These are the public methods because they have full circle and they take parameters, and the return type is right. So not only we need to have access to type, the class type, we then need to also separately be able to have access to the constructor, so that we can create an instance. And again, this method, this example showed that sometimes you don't need to be able to create a object of that type, which means you don't need to have access to the constructor, but you still sometimes need, in addition to that, you need to access to the type itself, because you want to declare that type, use that type as the type of a parameter that you pass to a method, right? And then once you have access to the type, and this means that somebody creates an instance and passes to this method. So this instance is supposed to be created somewhere else, and when somebody passes it, if we use obj, now we have access to only the public parts of this method, because this current class is in another package, right? All right, so I hope this is clear, that opening the type, access modifiers for the type itself, access modifiers for the constructor, so that we can create objects of that type, and then access modifiers for the state, which means fields, access modifiers to the behavior of the class, which means methods, right? Static methods, non-static methods, etc. And now we saw that the first example was we had a class. So I'm going to make the constructor public again, so that we can create an instance. So this class is another package. It can create an instance of this type. It has access to this type, and it only has access to the public members, public fields, and public methods, right? I'm just showing the example for the fields, but you can assume that the same rules apply to the methods themselves, right? So a class in another package only have access to the public members of another type. All right, so this was the first example. So I am going to copy these and let's comment this out. And now let's create a class in the same package. Basically access modifier demo, let's call this 2, and then copy and paste that main method again. And note that first of all, this class is in the same package of the type access modifier. So Eclipse does, when you copy paste, Eclipse doesn't add the import statement. That's because when we discussed the concept of packages, we said that the default assumption that the Java compiler and also JVM, the runtime, does is that whenever you're inside a class and you declare a variable of some type, the default assumption is that this type should be located in the same package. And if not, then you have to define it actually as the fully qualified name. And we said that fully qualified name is tedious if you want to create many variables of this type. So you just declare it once as the import statement, and then use the type itself, right? So the purpose of the import was to make life easier for the people or the developers who write the source code. They don't need to write the fully qualified name every time. And the fully qualified name just tells the runtime and the compiler itself that they look at the class path, and from that they look at the fully qualified name to figure out the package hierarchy, and then they go inside the inner packages to really locate where the class file for that particular type is, right? So fully qualified name packages, they have a close relation with the class path and where we can find the actual compiled classes. And this is a topic we discussed in depth in the previous lectures. So if you want to refresh your memory, go and watch the previous lectures, right? So a class in the same package, we don't need any import statement for this access modifiers type because it's also in the same package. And then we have access to the constructor, no problem. Even if this class was not public, we still have access to the type because it still is in the same package. So any class in the package, they always have access to the type. Whether this class declaration is public or not, that doesn't concern the package. Every class in the package have access to the type. Now making the constructor private is another story, right? And what I would like to show you here is that if I go back here and just remove this public, and now the constructor is also triangle, which means now it's only package level access. So the same rules for the fields and methods, it also applies to the constructor. So public is allowed, package level access is allowed, private is allowed. What about protected? Protected is also allowed. So the same rules for methods and fields apply to basic constructor, because constructor is nothing but a special method. So you cannot directly call it. You have to use it with a new operator, because the return value of the constructor has to be treated in a special way, right? But then it's the same rules for access modifiers. And I think Java implemented this beautifully in the way that in the source code you have to explicitly declare access level for any field, any constructor, any method, because then it makes life easy when you read the source code. You don't need to figure out which fields are public because it's already there, it's written there, right? So in the same package, we don't need any fully qualified name for types. We can always access the type. Accessing the constructor is another story. Constructor has its own access level restrictions. We can always access the public fields of another type which is in the same package. We can access all the protected, because remember, protected means same class, subclass, and package. So allowed in the same package, right? Protected allowed in the same package, okay. And then private never allowed. So private means as soon as you are out of the physical scope of the class, you can never access that. So and no other type can ever be able to access the private unless you do some special stuff like Java reflection, which is an advanced topic. But for now, the rule is that private means no one is ever allowed to access it, not even subclass, which is the next example. Package level access, remember X4, we didn't write any access modifier explicitly, which means it gets the default access level, which is a package level access. So any type in the same package can directly access this. And again, I'm going to emphasize again that directly accessing the fields of another class is a bad practice. The best practice is to have getters and setters, right? So the best practice is to declare every field private and provide getters for the fields that you want to open to every other type, right? So that's the best practice. But right now it's in the just for the sake of understanding the access modifiers, I'm showing you that I'm directly accessing the fields. So for the classes in the same package, only private is not allowed. Everything else is allowed. Now what we're going to do, I'm going to copy this. Let's comment this out. Now we're going to look at the subclass in the same package. So access modifier subclass, and we're going to copy and paste the main method. Basically, actually what we want to do is we want to extend the access modifiers, right? And let's see, in the main method we still don't have access to the private part, right? And again, we have access to everything else. And note that this is a main method, so I'm creating a instance of the superclass. I could also create an instance of the subclass itself, right? am sub. So let's copy these, paste these, paste these, paste these. So again, subclass. So I'm going to set the type to the subclass. We still have everything works fine. Again, the subclass gets the same fields as the superclass. So subclass gets the remember, even the private part of the state of the superclass is still part of the state of the subclass. That's the whole business of initializing the superclass right before initializing the subclass in the constructor call. So they share the same state. The subclass gets all the state of the superclass, but the question is which parts of the superclass state does the subclass directly have access to, right? And that means only public, protected, and package level. So the subclass doesn't have access to the private parts. Now if I look if I define a method here, so public void just basically access test. So in this here I want to access the field, so I can use the this keyword, and let's see what fields I have access to. Obviously this access modifier subclass doesn't explicitly have any fields, so we only see the fields of the superclass. So we have access to x1, which was a public field. We have access x2, which is a private field, and x4, which is a protected. Remember, yellow is protected, blue is package level access. So as you can see, we don't have access to x3, which was private. We don't have access to the private state of the superclass or super type. Now I'm going to comment this out, and I'm going to create a same class. Let's call it access modifier subclass, but in a different package. So extends access modifiers. Yeah, and remember the type is public, so other classes in other packages can extend this, because in order to do anything with a type, first you have to be able to access it, which means it has to be open to you, which means it has to be public, right? And then if I copy and paste this method, so remember this one is inside another method, another package, and I'm going to say this, which points to my current subclass dot. And as you can see, now I only have access to x1, x2. x4, which was a package level access, is gone. So a subclass in another package only has access to the public. Of course, everybody has access to public, but then the protected ones are also open to a subclass in another package. So we don't have access to the private and or a slash package level state of the super type. So if subclass is in another package, we don't have access to we never have access to private, but then we also lose access to the package level. But we have access to public and protected. And that's the whole business of adding this protected, because a lot of times other classes in other packages want to extend your class. That's the whole business of object-oriented programming and inheritance concept. And therefore, sometimes if the fields are all private, it makes life difficult. So you want to, as default, if you are thinking about inheriting from your super type, then in the definition of the super type, you want to define some fields as protected, so that the subclasses also access to them, regardless whether those are in the same package or in other packages, right? All right, let's finish this topic. Setting the type of a variable, it's the same. We've discussed this before. It could be a primitive, it could be another class type or interface, any other type, right? All variables must have a type, because Java is a statically typed language. You can use primitive types such as int, float, boolean, etc., or you can use reference types or pointer types. Reference in Java means object types, right? Such as a string, arrays, object. Naming a variable, again, we've seen this before in the Java language basics. All variables, whether they are fields, local variables, or parameters, follow the same naming rules and conventions. The convention is Pascal case for declaring types, camel case for variables, methods, fields, etc., that were covered in the language basics. We've seen them. The main thing is that a name of something cannot start with a numeric literal. It has to start with a alphabetic literal. In this section, be aware that the same naming rules and conventions are used for method and class names, except that the first letter of a class name should be capitalized. And again, this is not a compilation error if you don't follow it. It's the best practice or the convention. And it's called the Pascal naming convention. The first or only word in a method name should be a verb. So again, I wouldn't personally follow this rule that much. This one that says that the first word in a method name should be a verb. And usually, this is a good indication that you are actually calling a method, because methods are actions or behaviors, which means methods do do something, right? That's why maybe here when I defined this method, I said do nothing, right? Now obviously add is also a verb. So again, it's best to have some sort of verb in the name of your method. Then it implies that this is something that actually does some action, right? Something happens. For example, if you define a method that checks for a condition, the best practice to start it with is something. For example, public, it has to return a boolean, right? Boolean means true for is a public class, and then we can return, for example, true with letters, small letters, right? So is means we are, so the convention in Java is that if your method returns a boolean, typically you start with is or has, for example, basically has a public field, for example, something like that. Is or has, it checks for some sort of condition, so and returns boolean. So you want to start with is or has. So I hope you enjoyed this lecture and now have a very solid understanding of details of the class declaration and then the access modifiers. These are very important concepts, so I highly recommend you to review this material as much as you can. So please stay tuned, and I'll see you in the next one.